Okay, development by triangulation. This is basically taking a drawing and turning it into a flat shape that you can fold to make the object. Now this is going from a square, which you can see here, to a rectangle on the bottom. And I actually made this shape that you could have cut out of, like, say, sheet metal to make a hopper like this that goes from square to a rectangle using this process of development of a transition piece. A transition means changing from one thing to another, in this case a square to a rectangle. So it's a transition piece, and you are creating a development, which is a thing you fold up. You used to call it a net in mathematics. You know, when you take your cube and you break it open until kind of looks like that. 1, 2, 3, 4, 5, 6 sides. Now it's very simple for a an object that is vertical and horizontal. When you start dealing with planes that are doing, in this case, you can see here the sides are sloping in like that, and these two sides are facing out. So what you need to do is you need to start thinking about the shape of these objects. So in this case, we have a square at the top and a rectangle at the bottom. Now, when I first looked at this shape, you won't have the benefit of having this object in the class with you, or in the exam with you. So you need to start to try and visualize what you're looking at. Okay, now you can see these dotted lines, and that's a little bit of a hint that these sides are sloping in because they're covering the lines you can see in the bottom. Okay, so you're looking into this object. Okay, so the first thing you need to do is label. You need to label your bottom and your top. So we're going to label the bottom with letters and the top with numbers. Okay, and we're going to go clockwise. So on this bottom rectangle, the rectangle, we're going to go A, B, C, and D. And on the top square, we're going to go 1, 2, 3, and 4. So they're the first things you need to do. Label top, and we did it with numbers. You can do either. And in the bottom, letters. Okay, and it's going to be clockwise is a good convention. So that was the first step. Then what you need to do is you need to label the bottom as here as well. So if we tilt this up, okay, we know on the bottom we've got here A and B. So on the bottom here we write A, B, and these would be points going away from you. So that view, all you can see is a dot of the AB because it's going away from you. Okay, so you need to think about this for a little while. On the top, this 1, 2, right, when it tilts it, it becomes a point as well. Okay, 1, 2. Down here, CD is once again, we know that the CD is the bottom here, but when you look at that view, it's going away from you, so it becomes a point. Okay, and then the top becomes 3, 4. Now you've got to remember, one of the rules here is if it's a point view in one of these views, then in the other view it is a true length. Okay, so point 3, 4 is going away from you. It's a point going away on this bottom view. So in this top view, that's a true length. Okay. The other thing that you've got to remember is that if it's horizontal in one view, it's going to be true length in the other view. So you can see here that that's a horizontal length 1, 1, 4 or 2, 3. And in this view, it's a true length. It's actually a true length in both of them, because you can say that vice versa. If this is horizontal, then this one's true. Okay, so horizontal, just remember those two rules. Horizontal in one view, true length in the other. Point view in one view, true length in the other. Okay, but you've got lots of views that are lines that are not true length. So when you were dealing with a cube, it's pretty easy to tell that, you know, horizontals and verticals are true lengths. But this length here, say A1, okay, it's going to be harder to ascertain the length of that particular line, because of the angles that are involved. Okay, so this is why we need to use triangulation. Okay, so we've labeled. We have to remember those rules about if it's point view in one view, it's a true length in the other. If it's horizontal in one view, it's a true length in the other view. Okay, they're the two rules that you need to remember. If you're not clear on those rules, ask me and I will explain it to you a different way. Then we draw a line, we transfer a line top and bottom from this front view, and just try and get it as accurate as you can. Don't do it like I just did. Nowhere near right. So once you've done that, what we need to do is we need to get a right angle, because this is how we're going to work out lengths that we don't know. We're going to use this area here to calculate the line lengths that we don't know. Okay, and then we need to decide on a seam. I'm going to start with this line here, 1A. Now, it's not a point view in any of these views, and it's not horizontal. So how do I determine the length of it? We use a thing called triangulation, and we also use this this line. So what we do is we put our compass on the top view, and we go like this. We get it between the 1 and the A. Okay, you might want to get a better compass than the one I'm using here, and you swing an arc just like that. Okay, and then we just draw a line from here to here. Now, I kind of hear what you're saying. You're saying that this line here from 1 to A is a true length. It's not actually, okay, because you can see here that in this view, you're dealing with it coming out towards you and sloping in. Okay, so it's a little bit harder than it looks. Okay, so like I said, 1 and A, swing an arc, draw a line. Okay, so that's the first part of the process. So that's our first line. We've decided A1 is our seam, and it's 3 centimeters long. So I'm going to draw a 3 centimeter line, and I'm going to call it A1. Letters on the bottom, numbers on the top. And then we've got to say to ourselves, well, we go from 1 to where? We go from 1 to 2. Okay, because we're going to go numbers along the top, letters along the bottom with this system. Okay, so we're going to go 1, 2. Now, we know that 1, 2 is in this, if you look at this view here, 1, 2, when we look at it here, it's a point view. Okay, it's going away from you. So if it's a point view in this view, then it's a true length here. So we know that we can just put our compass between 1 and 2, and that will give us the distance for this line. Okay. Now you might be saying, well, why don't we just measure it and draw it? Well, you have to get the angles right. Okay, and this is where the difficulty comes in. So we're going to go 1, 2. Now swing. Whenever you swing an arc, swing it big, because you'll be surprised by where the intersections are going to happen when you actually have to work that out. Okay, so swing a big arc. Okay, 1, 2. So this is going to be going from 1 to 2. But where do we know on that arc to draw the line between 1 and 2? We need to find another point that goes to the point 2. And the way to do that is, this is where the triangulation comes in. I know that I've got my point A here, so I'm going to draw a line from A to 2 on this face. We triangulate all the faces in this process, okay? So A to 2. So what I do then is I grab my compass and I put it between that line, A to 2, the triangulation, and I draw a line that goes like that. And then, you guessed it, I go like this. Okay. Now we said that this was A1. Okay, you want to make sure that you then label your line. So this is A2. Okay, so I get my compass and put it between here and here to get my distance. I put this on the A and I swing my line. Okay, where they intersect is actually where 1 and 2 happen. Okay, so that point there, draw the point of intersection and then join them up. So now we've got 1 to 2 done. Okay, now you might be saying, what do we do next? Well, we're going to go A to B. Okay, now we know AB is a point view, so we know that AB is going to be a true length in this diagram. So AB is not a problem at all. We just put it on the actual diagram and we swing an arc. Now swing an arc that's nice and large. Okay, so that we're not going to have a problem finding the point of intersection. So that's our AB, but where do we draw it between here and here? It could be anywhere along this arc. We need to find another point that's going to be. Okay, so we've got AB. What other point do we have going here? We need to find a point from 1. Okay, now we know that these are symmetrical. Okay, so if A2 is that distance, then this is also going to be, because if I draw this line in, I could draw it and do the whole process of measure it here, swing the arc, draw the line, but it's going to be the same as A2. So 1B is this line here. Okay, so what I do is I pick up this line over here and I swing an arc. And see how I was swinging from A? That's wrong, isn't it? Because it's 1B. Okay, so we need to be swinging it from 1. That's the next thing that can cause you problems. If you swing from the wrong point, if you're completely wildly off, it usually means you're you're in the wrong position. You're swinging from the wrong point. Okay, so 1B, swing the arc and do it more accurately than I just did, and you get that point there. Okay, so make sure you swing your arcs nice and wide and accurately, and get a better compass than the one I'm using. And this is our point there. Okay, so we've gone AB. Now we can join 2 and B together because we know those 2 points. If you know 2 points, you can join them together. That's our first face that we've done. Okay, so now we need to go from 2 to where? Well, you know how to count. You go 2 to 3. So 2, 3 is horizontal in this view. So if it's horizontal in one view, it's going to be true in the other view, and actually they're both the true distances, so it doesn't really matter, but that rule works. Okay, so 2 to 3. So we're going to go 2 to 3. We're going to swing our arc nice and wide. 2 to 3. That's our 2 to 3 arc. We need to find another line that goes to 3. We know B, so we're going to take our line B3. So we've got B and 3. So now we need to, you guessed it, create a triangle in that face. Triangulation of the faces. B3. Then we grab our compass, put it on B3. Boom. Then we come over here to this graph here, draw the swing and arc, and this is the true length of B3. Okay, so I'm going to take my B3 length off here, and I am going to put it on B, and I'm going to swing it, and where they intersect, okay, is our point 2, 3. Okay, then what do I need to do? I need to go from B to C. Okay, now BC is a horizontal, so it's a true length in the other view. It's horizontal, it's a true length here too. Okay, so BC, true length. Okay, so I'm going to swing my arc, which is true length, BC. Now I need to find another line. So 2C is going to get me where I want to go, but we know that B3 is going to be the same as 2C because they're on the same face and the face is symmetrical. Okay, so it's going to be our 2C is the same as our B3. So C3 or sorry, 2C is going to be the same. So this is C2. Let's put the letter first. Doesn't really matter. This one here is the same as that one there. Okay, so we know we've already got that distance. I'm going to grab that distance. I'm going to put myself on my 2, and I'm going to swing the arc. And where they cross, you guessed it, that is C. And we draw the line. And then we can draw in the line between 3 and C as well, because we've got 2 points we know. That's 2 faces, 2 more to go, and we've completed our development by triangulation. So we're going to go from 3 to 4. 3 to 4, 3, 4 is an end point view. So in this view, it's real. You can kind of work out that looking from the top, the square is going to be real length anyway, can't you? So 3, 4 is a real length. So we're going to swing our 3, 4 length. Okay, nice big swing, a nice big arc that you swing. Then so that's going to be our 4. Then we're going to find something else, and we haven't done any triangulations on here, so we need to go from C to 4. Okay, so we create that triangulation. But guess what? If you're clever, you could do the whole process of do it, swing it, work it out, but you know it's going to be the same as 2A, okay, because these 2 faces are symmetrical. So C4 is the same as 2A. Or, yeah. Okay, so you could go C4. Okay, so we can use that distance there to work out from C, swing it through to 4. That's our point 4. And then we need to do C to D. And we know that C and D are true lengths because they're a point view in the bottom view. CD. But we need to find a point that runs to here, okay? And we know that's the point we've done, we just did C to D, okay? We need another point that runs to D. From 3, we could do 3D, and 3D is going to be the same as C4. Okay, so we can take that view there, take our 3, swing our arc through our line, that's D, that's C4, and then we need to do one more plane. So we're going to go from 4 back to 1, because we've got 1, 2, 3 so far sides, okay? So we need to go 4 back to 1. We know that that's a true length. And I've run off the page, okay? But the process continues exactly the same as what we've just been doing. You need to, any lengths that aren't real, you need to calculate them using this and the length in the top view by swinging the arc. And then you need to work out where the intersections are by finding 2 points that lead to the point that you're trying to find. Give that a crack, and we will do it in class, and we will get better at it as we do more of them. See you in class. Okay, last bit, we ran off the page, so I've added a bit of paper to the page. Hopefully this will help. So we just need to go from 4, you guessed it, back to 1, which is our seam. Okay, so we've only got 3 faces, so we need to do that last face. So 1 to 4, as you can see, 1 to 4 is a horizontal in this view, so it's a real length here. So we need to get that length down here, 1 to 4. And we're going to swing our arc. And we need to find something else that'll run to the 1. So we've got 1, 4. We need to work out our D1. Okay, so we haven't got a D1 in the face, but we'll know that D1 is going to be the same as B3 because these two faces are symmetrical. Okay, so B3 is also going to be like D1, so we can use this one here. So we grab this length here, our D1, we swing from D across, and we end up where they intersect here. And then we need to do our D to A, which once again we know AD is horizontal in this, so it's going to be a true length here and vice versa. So we swing down and we need to find something else that will go to A from D. So that's our point 1. We need to go, we can go from 4 to A. And 4A is going to be the same as that one as well. Okay, because it's going to be the same. These two are equal, and these two are equal. Okay, so we know that our 4A is like our B3. Swing from 4. We find the point of intersection. It's back to our A. That's where our seam is. And we do that. So that's our shape. I am going to photocopy this and cut it out, and I'll show you what it looks like. Okay, folks, I've printed this out but enlarged it, and we cut it out. And then we just fold along these lines. Actually, let's fold it so we can see the line, so we know we're on the line. Now, obviously, some inaccuracy has crept into this whole situation, but you can see from the bottom we have a rectangle, and from the top we have what approximates a square, and that is our side view. So we've actually stuffed up a little bit here because of inaccuracies in swinging and whatnot, but that's how you do a transition piece, rectangle to square. Follow the video, practice, you will get better at it.